Hey guys, welcome to this video. Today is November the 10th, lecture number 24. So today we'll be practicing with Java, but first off I just want to make a couple of updates. First off, syllabus is updated, so I didn't upload it to the Blackboard yet, but I just want to let you know that, well, first off, if you want to get some extra credit, okay, to bring up your grade, you can actually read this section in the syllabus. But the stuff which I added here is, the first one is this: no extra credit will be added after the reading day. So please, please, please manage all of that before the reading day, because otherwise what happens is that students after the final exam, they get frustrated and then they send me a lot of questions, and they want to, and it's very difficult to manage that time. I will not be able to reply to all of you properly. So that's why please manage all the opportunities to get extra credit before that. That's number one. Number two, there will be a few logical thinking, math, probability, geometry problems available on my YouTube channel. Here's the link. So I have prepared 9 problems, and they will be slowly appearing. For example, today you're gonna see the first one. It's a problem about two candles. Okay. If you solve this problem, show the solution to me, I'll give you 0.5% extra credit. That's the yeah. So there'll be 9 of them. They'll slowly appear. I have already recorded that. I just need to prepare the thumbnails and all that stuff. So you can solve any amount of them and present me the solution, proving that you solved them yourselves, and be ready to answer additional questions. Each one of them is worth different amount of points. So for example, this one, which you're going to see today, is worth 0.5. I will be able to add up to 5. I'll be able to give you 5%, up to 5% of extra credit for solving them, right? So for example, there'll be one of them which is worth like 3%, 2%, 1.5. Okay, so we'll give you as much as this, 5% extra credit. Okay, hope it makes sense. That is an opportunity to first off have fun, improve your logical thinking, and which is very, very important for computer science and math majors, in my opinion, math major students and computer science major students. That's the first update. The second update, I just want to show you the calendar. So I remember last time you guys expressed the concern that it's very inconvenient when you have a class on Tuesday and then midterm on Thursday. So luckily in this semester that's actually not the case anymore, because we only have a final exam, right? So the Wednesday is the last day of classes. Our last class will be on Tuesday, and the final exam will definitely be after the reading day, which is at least a week after. So this problem will not appear anymore in this semester. So I hope it makes your life easier. What else? Yeah, and today we'll be having a practice. Okay, so Java practice. Today I want to solve one of the problems which appeared recently in the lab. I think it was like 2 weeks ago, or like, yeah, a week and a half ago. This one is a problem with like 2 stars, you see, so it's like considered to be complicated. I actually, so I remember I solved a couple of years ago, and I was thinking about maybe solving that first and giving you a solution, and then I decided not to. So I will be solving this problem for the first time in a few years. Yeah, so hopefully that is a good decision. You'll be able to see my thinking process, all my mistakes. I'll be able to correct them, and it will be very, very disappointing if I will not be able to solve it. I hope I'll be able to solve it. I hope I'm smart enough to solve this one. Okay, so open up your Eclipse. Just follow me. Okay, I remember Benjamin said that he likes this type of stuff. Okay, so I'll be coding. You'll be able to pause everything. I'll try to explain as much as I can. You'll be able to re-listen to that explanation. Maybe that helps. Okay, so open up your Eclipse. Follow my lead. I'll be solving everything here in the online compiler. So let's go. Credit card numbers, right, follow certain patterns. A credit card number must have between 13 and 16 digits. Okay, that makes sense. It must start with either 4 for Visas, either 5 or 5 for MasterCards, or 37 for American Express, or 6 for Discover cards. That makes sense, right? So you can't really just come up with like random 16 digits, and that's not going to be a valid credit card number. In 1954, blah, 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 algorithm for validating credit card numbers. The algorithm is useful, blah, blah, blah. And that's basically our task, right? So our task is write a program that prompts the user to enter a credit card number as a long integer. So why is it long integer? That's because we have 16 digits. 16 digits cannot fit into an int data type, right? Because int is a consists only of 4 bytes. 4 bytes is like 4 billions or like 2 billions, right? So obviously 16 digits is not 2 billions. That's much more. That's why we need to have a long data type. So we write a program, user enters some number, and we need to basically display if the number is valid, for credit card number. Okay. Yeah, so that's our goal. And I really like this problem because it actually, although you're only in the first, at the beginning of your career, that's your first serious computer science class. However, you will be solving like real life, real world problem. I remember I was not working, of course, for Visa or MasterCard for any of those companies, but I was developing a lot of mobile apps. In a mobile application, I remember when the user types in his credit card number, I always needed to check to make sure that the credit card number is valid. And what do you think I was doing? I was doing exactly the same thing, just not in Java, but in TypeScript, which is JavaScript, which is almost similar, which is very similar to JavaScript. But anyway, so that knowledge can be very, very useful when you graduate. That's why I like this problem a lot. So we're given 1, 2, 3, 4, 5 step process. Okay, in order to validate that, keep in mind that it has 2 stars, right? So it's not going to be easy, as is your homework. So let's dive into that. We're given, well, first up, let's discuss what the procedure is. First off, we need to double every second digit from right to left. So imagine this is our credit card number, right? And we need to double every single digit from right to left. Keep in mind that they start counting from right to left, right? So from right to left, they start counting digits not from 0 but from 1. So as computer scientists, we do count everything from 0, but they start counting from 1. That's why. Well, yeah, so they will consider 6 as the first digit, then 2 as the second digit, then 6 as the third digit, and so on. Anyway, so we need to double every digit which is located at the even number, at the even position. If doubling of a digit results in a 2-digit number, for example, check this out, 6 by 2, right, is equal to 12. So if we double a digit and it results into 2-digit number, 1, 2, 12 is a 2-digit number, we need to add the 2 digits to get a single-digit number. Okay, so in this case, if we multiply 6 by 2, we get 12. We still need to add 1 and 2 together to get 3. Okay, so we don't stop. We don't stop at that. If we multiply 2 by 2, we get a 4. That's 1 digit. That's fine. Nothing changes. If we multiply 4 by 2, that's 8. Totally cool. If we multiply 8 by 2, that's 16. Totally cool. Oh, sorry, 16, right? So we need to add 1 and 6 to get 7. Hope it makes sense. So that is the first step. That's the first step. So 6 is the first digit, so that doesn't count. 2 is the second digit, so that it gets doubled. 6 is the third digit, doesn't count. 2 is the fourth digit, so it's doubled, and so on and so forth. The last digit is 4, which is the 16th digit out of 16 digits, right? And that gets doubled as well. So that's the first step. Step number 2. We need to add all single-digit numbers from step 1. Okay, so we get this 4, 4, 8, 2, 3, 1, 7, 8, and we need to add them together. 4, 4, 8, 2, 3, 1, 7, 8 to get 37. Cool? That's easy. Number 3, add all digits in the odd places from right to left in the card number. So here we need to add odd digits, sorry, odd places, right? So that was about even places every second, but here we're talking about odd places. So what do we have at odd places? 6, 6, 0, 8. Am I right? Yeah, 6, 6, 0, 8, 0, 7, 8, 3. 3. Is that the last odd digit? Yeah, 3. Perfect. Awesome. That's equal to 38. Okay. Perfect. Did that. Now, number 4, sum up the results from step number 2, step number 3. So basically 37 plus 38 gets 75. Okay, makes sense. Number 5, if the result from step 4 is divisible by 10, then the card number is valid. So 75, is it divisible by 10? No. So that should be invalid, right? Otherwise invalid, for example, yeah, that's our number. It's invalid. Okay, cool. But the number This number is valid. Okay, awesome. Write a program that prompts the user to enter a credit card number. Okay, I'll explain that. So what do we need to do? We need to, first off, make sure it starts with either 4 or 5 or 37 or 6. Or, first off, we need to do that. And we also need to go through that procedure. So if both of them, if both of those conditions are true, if it starts with one of those numbers and all of that, like the final number is divisible by 10, then the number is valid, okay, then we're good. Otherwise, it's not valid. We also given, that's kind of a hint, and it's very good that they did that, we also given the methods, the signature of the methods, which we need to implement, and that kind of makes our life easier. It basically breaks down into steps, okay? So first off, okay, what you need to do first is to copy all of that into your Eclipse. I'll be copying it over here. Public static boolean is valid number. Okay, public static boolean is valid number. Lon n. I think it's just is valid, right? Yeah, is valid. Okay, lon number. Okay, is valid. Okay, what does it do? Returns true if the card number is valid. Okay, so that's basically the most important method, and this method will be calling all other methods which just support this method, right? So that's the main one. So I'm assuming we'll basically be calling this method from the main method, like this. It will be providing a number. Okay, cool. Moving on. Sum of double even place. Okay, sum of double even place. So public static int sum of double even place. Okay, lon number. Okay, so that's the result of the step 2. What is the step 2? That's the step 2, right? Okay, so step 2 is basically step number 1, and after that we're doing step number 2. Okay, awesome, makes sense. Moving on. Public static int get digit. Public static int get digit. Okay. What are we passing? Now we're passing an integer, int number. Okay. Int number. Okay, so what does it do? Return this number if it is a single digit. Otherwise, return the sum of 2 digits. Okay, so what are they talking about? They're talking about this step number 1. If we're passing 2, then we need to return 4. No, hold on. Yeah, if we pass in 4, then it's going to return 4. But if we pass in something bigger than 9, right? For example, 12, right? In this case, it needs to return 3. So it's useful for this step, for step number 1. Get digit. Moving on. Public static int sum of odd place. Place, not places, place. Sum of odd place. Public static int sum of odd place. Okay, also, I guess it's lon number. Am I correct? A lon number. Sum of odd place. Okay. So, what does it do? Return true. No, hold on. Return sum of odd place digits in the number. That sounds like we're doing it in step number 3. Add all digits in the odd places. Okay. That makes sense? Moving on. What else do we need to do? Get size. Okay. No, hold on. Prefix matched. Public static boolean prefix matched. Okay. Boolean. I'm gonna copy that from here. Public static boolean prefix matched. A lon number and int k, I think. In D. Technically it doesn't matter, but let's follow the guideline. Return true if digit D is a prefix for number. So what are they talking about? They're talking about this step, right? So what they're saying is we need to call this method, provide our credit card number first, and then the second parameter we need to provide 4, 5, 37, or 6, right? And we need to return true if this credit card number starts with 4, or 5, or 37, or 6. Okay, so basically we'll be calling this method like 4 times. And if one of them returns true, that means we're good. It starts with either 4, or 5, or 37, or 6. You'll see later. Moving on, public static int get size. Public static int get size. So copy this. Public static int get size long number. So what does it do? Returns the number of digits in D. Okay. Yeah. So basically, if we pass in this number of a credit card, it needs to return us 16 because this number contains 16 digits. 16 digits. Last step, public static long get prefix long number int k. Get prefix, right? So long, we need to return a long. Okay. Public static long get prefix long number int k. Okay. So what do we do here? Return the first k number of digits from number. Okay, so number means this number. If the number of digits is if the number of digits in number is less than k, it returns number. Okay, so here's what it means. Here's what it means. Let's say our number is size. Let's say our number is 1, 2, 3, 4. Okay, let's say so we pass a number as 1, 2, 3, 4, and our int k is equal to 1. That means we need to return the first digit, okay, which is 1. If we pass in 1, 2, 3, 4, and the k is 2, that means we need to return first 2 digits, which is 12, like 1, 2, right? If we pass in 1, 2, 3, 4, and int k is equal to 3, in this case we need to return 123 as long, right? So we're returning the prefix of this number. How long is the prefix? It depends on what k is. If k is 2, that means we need to return 2 digits. If k is 4, for example, if we have 1, 2, 3, 4, and k is 4 digits, in this case we need to return 4 digits of 1, 2, 3, 4, which is basically the same number. So we need to return the whole thing. Okay, and here's what it says: if the number of digits, right? So for example, if the number of digits in our number, so if in this number we have few digits, right? For example, if our number is 1, 2, 3, 4, and our k is, let's say, 10, in this case, we cannot extract 10 digits out of 4-digit number. That's impossible. In this case, we're just returning the whole thing. We're returning 1, 2, 3, 4. Cool. Cool. Hope it makes sense. So why do we need that? Where do we need that? We need that, I'm assuming, in which step? Over here? Prefix. Oh yeah, okay. So we'll be over here. So when we need to understand what the prefix is, and we need to compare that to 4, 5, 37, and 6. Okay, so we'll basically be chopping off chopping off the first digit on the left, right, or chopping off the last digit. Oh, like 2 digits, 37. Yeah, so that's why we need that. Okay, I think that's it. That's it. And now I think we can get started. So you're looking at this problem, your mind is blown away completely, you have no idea what to do. That is absolutely normal. That's very soon you'll get immune to that. Okay, so it happens all the time. You don't have to understand everything at the very beginning, and that's what engineers do all the time. Especially, well, not sure about others, but computer science definitely face problems they've never solved before all the time. What do you need to do first? First off, my recommendation is to start with something which is super simple, something which you can definitely understand. Start with the easiest stuff. So which of those methods is the easiest? This one, okay? Get digit. Okay, so we need to return this number if it is a single digit. Otherwise, we need to return the sum of 2 digits. What does it mean? Get digit. Okay, so that means, for example, if the number is 4, that means we need to return 4. If the number is 12, that means we need to return 3 because 3 is the sum of 1 and 2. That's pretty easy because we know we know that our number is either one-digit number or two-digit number. How do we know that, you may ask? We know this from the following constraint. We are multiplying by 2 one digit, right? So the biggest digit, the highest digit possible in our base 10 system is 9. So if we multiply 9 by 2, we get 18, and it's impossible to get anything bigger than 18. 18 is a two-digit number, so we're definitely going to have at most two-digit number. So we're going to have either one-digit number or two-digit number. Okay, so if number is less than or equal to 9, then we can return number, right? Else, so if number is 10 or more, 10 is already a two-digit number, right? In this case, what do we do? In this case, we need to let's say sum is equal to 0, right? And then, so what do we need to do? If we need to add, if let's say it's 12, we need to add 1, and we need to 1 and 2, right? How can we do that? As we discussed last time, so we can do number divided by 10. Well, let's do modulo 10. In this case, that gives us second digit, which is 2. Okay, so sum will be equal to number modulo 10 plus, how do we get 1? So we just divide number by 10. Okay, so number percent sign 10 plus number divided by 10. So in this case, for example, if our number is 12, number percent sign 10 gives us 2 plus number divided by 10 gives us 1, so we get 3. Okay, hope it makes sense. And we need to return number, return sum. Return sum. Cool. Cool. Okay, so at this point we wrote our first method. We think it works, right? Most likely. However, we can't be sure. So even though this one is pretty simple, I would highly recommend after writing every method, try to test it. Try to test it. How would I test it? Let's try to do the following. Let's try to pass some kind of a number, and let's see what happens. Okay, so what I need to do, I'm going to print out get digit of, let's say, 12. In this case, I need to, the output should be 3, right? So I will not be able to run it. Why? Because I have these methods which are promising to return boolean, and it doesn't return anything because it's empty. That's why I'm going to comment them out, kind of pretend that they don't exist for now. Okay, cool. So now let's run it. I would, yeah, perfect. It's 3. Now let's, first off, also important thing: do not stop after one try, after one attempt. Test more numbers. For example, 6, 5. Is it 5? Please tell me it's 5. 5. Okay, perfect. Now let's do, I don't know, 18, right? So 18 is the biggest. 9, okay, that's good. And let's do 10. 1, perfect. Awesome. Looks like it works. Okay, of course, obviously, the more numbers you test, the more you'll be able to understand if it works correctly. But looks like it does. Looks like it does. Cool. Okay. What else can we solve? What's the easiest thing we can do here? So get digit is 1. Get size. Okay, so the size of the number. Okay. Get size. Where is that? Get size. Get size. Okay. So here, what's the idea? The idea is that if I have a number like this, right, I need to return 1, 2, 3, 4, 5, 6, right? Because this number contains 6 digits, I need to return 6. How can I do that? There are obviously like huge amount of ways of doing this. A lot of ways. The easiest one I found is to convert this number to string. Okay, basically if I have this number, right, convert this to string like this, and then all strings objects have a method called length. Okay, and in this case, string.length will return me how many characters, right? So those are not really like digits or numbers anymore. Okay, characters. How many characters do I have and that's going to be equivalent to how many digits I have in that number. So length, okay, but first off, we need to convert number into a string. How can I do that? So let's Google it. Convert long into string, Java. Long to string, okay, perfect. Long to string, okay. So I think that's what it's gonna do to string, right? Yeah, so number dot to string is going to convert, well, let's make it this way. So string a number dot to string. Okay, so let's run it. Let's see if it compiles. No, it doesn't. Ah, long dot to string. No, Java long to string. Now I'm run. Bam, bam, bam. No, that sounds like a JavaScript. Ah, okay, so I can add plus. Ah, okay. That makes sense. I can add plus. So I can do, for example, number plus. Okay, so I'm basically adding number to completely empty string. In this case, it's kind of automatically going to convert number into a string and add nothing to it, and it's going to be a. That's going to be assigned to a. Let's see if it works. No, it doesn't. Ah, I need to return something, right? I need to return, let's say, 0. Perfect. Okay, it compiled. It works. Awesome. So now let's do. Okay, and now let's return a dot length. Okay, and that's what I'm going to pass over here. Get size. Let's say 101. Is it going to return 3? No. A dot length. Ah, it's a method. A dot length. Perfect. Okay, so now what if I do 101, 101? So now it should be 9. Is that going to return me 9? Perfect. Okay, looks like it works. Looks like it does work. Awesome. Cool. Yeah, that's it. That's it for this one. Get size. Okay, moving on. What else? What else can we do, which is like very easy to do? Get digit. We did that. Get size. Did that. Sum of places. That sounds super difficult. That sounds super difficult. Prefix matched. Return true if digit D is a prefix for number. Okay. Get prefix. Okay, this one sounds like very easy to do. Not very easy, but easier than all other methods. Get prefix. Okay, so what do we need to do? We need to return. Yeah, so we need to basically chop off the first k digits from the number and return it as a long number. Okay. Get prefix. Okay. So what does it mean? That means if we're passing, for example, 1, 2, 3, 4, 5, and k is, let's say, 2, that means we need to return 1, 2. Sorry, yeah, 1, 2, 12 as a number, right? Okay. So how can we do that? Yeah, I would actually highly recommend pausing this video now and thinking about that on your own instead of getting the solution. Okay. But how would I do that? In my opinion, the easiest way to do that would be the following. Again, convert this into a string, and after doing that, just return kind of a substring of first two characters, 1, 2, and convert that into a long number. So how would I do that? First off, I would do same thing as this. Well, first off, okay, hold on. If k is bigger than, yeah, okay, so I need to do this first. I need to convert that. I need to find out how long the number is. Okay, int a is equal to number plus quotes. Okay, and after that, if k is greater or equals a dot length, okay, then return true. Oh, sorry, return number. Okay, what does it mean? If my number is 1, 2, 3, 4, 5, and my k is 6, I mean, I can't really extract 6 digits out of a 5-digit number, right? So I have to return in this case like just an original number. which is this one. Okay, if my number is 1, 2, 3, 4, 5, and my case 5, in this case, same thing. Basically, I have to return the whole thing, 1, 2, 3, 4, 5. Okay. Okay. Else, or without the else, it doesn't really matter. So if we proceed, then what do we do? In this case, if I have 1, 2, 3, 4, 5, and k has to be smaller than that, let's say 3. In this case, I need to return 1, 2, 3. Again, I converted this into a string. Now I basically need to return the first 3 digits, the first 3 characters of this string. Okay, so basically I have a string A. I need to extract the first 3 digits. In other words, I need to find a substring. How do I do that? Let's Google it. Substring in Java. Substring, yeah, something like this. String, substring, begin index. Yeah, okay, that's the one. That's the one. Okay, so here's how it works. Here's how it works. Ah, no, substring. Okay, hold on. No. It can't be right. How? Yeah, okay. Yes, okay, makes sense. So we need to call it on A. Okay. Yeah, so here's what we need to do. We need to say A, that's substring, and we need to provide 2 numbers. The first one will be the index of the first character, which we start from. In our case, it's going to be 0, right? Because we're always going to start from the very first character. And here is the index which we need to end upon, right? So for example, if we need to chop off 3 characters, that means we need to return 1, 2, 3. That means we need to return the 0th character because we start from 0, first and second, okay, and second, which is what? K minus 1. Yeah, so we need to return 1, first one, second one, and third one, right? But if we start counting from 0, 0, 1, 2. Keep in mind that usually with these methods, the end index is exclusive. So I'm pretty sure it's gonna write here. Yeah, so you see, it extends the character at index and index minus 1. Okay, so unfortunately, what it does, and it can be like not that, well, it's, yeah, so anyway, what it does is that it starts at this index 0 and it ends the index before k minus 1. Okay, so it's, for example, if I put like numbers, let's say, I don't know, 0 and 2, in this case it's going to start with index 0 and it's going to continue up until 2, but it's going to finish the one before 2. So it's going to include only characters at the position 0 and 1. Okay, not excluding 2. So that's why if I want to return from 0 to, let's say, 3, in this case I need to pass the 0, right? And the first 3 digits, right? 0, 1, 2. So I need to pass k. So again, if I want to return the first 3 digits from 1, 2, 3, 4, 5, I need to get a substring between 0, which is the first, very first digit, and up until the digit which is located at k minus 1 position. K minus 1 position. So k minus 1 is 2. So 0, 1, 2. Okay. So that's how it works. It needs to return. That's going to return me 1, 2, 3. Okay. Yeah. So from 0 to k, and that's what I need to return. Right. I need to convert that into ln. Okay. Ln ret is equal to a dot substring, and now I need to convert that number into ln. How would I do that? Let's Google convert string to ln Java. String to ln Java conversion examples. Ln parse ln. Okay, makes sense. Ln parse ln. Okay, like this. So basically saying ln dot parse ln, and inside we're going to provide our string string. Okay, long parse long, and inside we're going to provide our string. What is our string? It's basically a substring of A, right, from 0 to K. And then we're going to return RET. Okay, so let's try that. First off, let's compile. Let's see if it compiles. No, it doesn't. E.length. I misspelled length. So you see, I wrote a little bit of code compiled. I wrote a little bit of code compiled. That actually prevents me from a mistake which a lot of students run into. If you write the entire code and then if you write all the code at once, right, and then you run it, and the mistake happens somewhere, it'll be very, very difficult to understand where the mistake is. But in this approach, I just wrote this method. If the mistake happens, it's definitely somewhere here. Okay. So that minimizes the probability of making a lot of mistakes. Okay, so it compiles. That means it at least doesn't have any syntax errors. But now let's try this method. So let's say that's our number. Now let's say our number will be 1, 2, 3, 4, 5, 6, 7, 8. And let's say we want to return first 4 digits. Okay, let's see if it works. Okay, 1, 2, 3, 4, 4. Perfect. Now let's say we're going to return 6. Perfect. Now let's say I want to return 10 digits, which is impossible, right? Because I only have 8. Okay, awesome. Yeah, so that returns the actual number. Cool. Yeah, moving on. What's next? So we already did this, and this. Okay, prefix matched. Okay, so this one, yeah, I think is a bit more. This one is the easiest out of all the ones which are left. Prefix match. What do we need to do? Return true if the digit D is a prefix for number. Digit. You see, the problem is that it's a digit. I don't like that. So I can't really specify 2-digit number. Is that what it says? Okay, so I don't like that. I'm gonna change it. I'm going to make sure I'm going to return true if the number D is a prefix for the number. Okay, so I'm going to avoid. I'm not even sure if it's a mistake or not because that doesn't make sense. But yeah, so I'm going to compare basically D to the first digits of number and return true if they're the same, and return false if they're not the same. Okay, how would I do that? Prefix matched. Okay, so what does it mean? That means if I'm passing 1, 2, 3, 4, 5, blah blah blah, right? So I can have like a huge amount of digits, and my D is, I don't know, let's say, what is it? Realistic, like 4, 5, 37, or 6. Okay, so let's say it's 37. In this case, I need to return false because 37 is not a prefix of 1, 2, 3, 4, 5, like blah blah blah. So if I have like 37 like this, in this case I need to return true because this number starts with 37. Okay. Yeah, so it sounds like a if-else statement, right? Else return false, right? Something like this. Return true. So the question is how would I do that? How would I understand that? Let's think. Well, it's the same thing, right? So if I convert this number into a string and then just compare 37 to the first digits, the first characters, if they're the same, then they're the same. Then I return true, otherwise I return false. Okay, so let's do the following. First off, I'm going to convert this into number, int a. So a is going to be my string, which contains this number. And then what? First off, it's unlikely to happen, but it's possible that there'll be a mistake. For example, if somebody made a mistake and he passed, for example, 3, but prefix is 37, then of course that's impossible to do. Then I definitely need to return false. So in this case, oh yeah, by the way, so let's do the same thing for D. So let's say B, and that's going to be D. So I'm converting number into a string and prefix into a string. So now I have 2 strings, A and B. Let's give some meaningful names. Number str and d str. So number is a string and digit as a string and d is a string. Okay, so now if the length, so if d dot length, if the length of my prefix is greater than d str, is greater than number str, okay, then something is definitely wrong. I need to return false. Okay, 100%. Then I need to return false. Okay, hopefully it's never going to happen, but that's kind of a sanity check. Moving on. How can I find out if my number, which is like this, starts with 37? So I basically need to compare the first digits of this and to my D. Okay, so I need to understand if this is a substring. 37 is a substring of this number. 37 is a substring of the string. So that sounds like, again, I need to manipulate the strings in Java. Okay, so let's Google if it's possible. So Java, how can I find that? Substring in Java. Substring. Check if substring in Java. Core Java contains. So contains would work perfectly fine. However, we need to. Contains doesn't make sure that our substring is at the very beginning. So that's a problem. That's a problem. Index off, last index off. Okay, so we did that. Pattern match find. Okay, Apache index off. I don't see that. Okay, I'll probably have to write it myself. Okay. Okay, awesome. Well, in this case, that's fine. So int length is equal to let's do dstr.length. Okay. So len is going to contain number is going to be equal to number of digits in my number. No, hold on, in my prefix. Okay. Then we already know how to extract the prefix, how to extract the first digits from the number. So, for example, if I do something like this, string. For example, if my len is equal to 2, I have 2 digits here, right? Then I need to extract 2 digits out of this number. So I can say, for example, int number str prefix is equal to number dot substring from where to where? From the index 0, because we always start with 0, right? Up until len. Right. So, for example, if our prefix has 2 digits, in this case, we need to extract 2 digits here as well. But keep in mind again that we start. Yes, for example, if it's 2, right, then in this case we need to go from 0 to 1, right, and then we stop, right. So again, it's exclusive. Okay, that's perfect. Okay, now awesome. So now we have a number called number str prefix, and now we have dstr, and we just need to compare them. How do we compare them? We just say equals number dstr. Yeah, number str prefix equals dstr. If they're the same, then we return true. If they're different, then we return false. Okay. Should make sense. Should make sense. So what do we do now? We need to test it. It sounds like it should be working correctly. First off, let's compile, and let's see if it compiles. If it doesn't have, okay, it does have some mistakes. Oh, number 49 here. Okay, number str. Okay, awesome. So now let's make sure if it works. Okay, prefix matched. So we need to pass. Yeah. So let's say this number in 10. So if 10 is a prefix of this number, then it should return true. Otherwise false. So in this case, it should return false. Let's see if it works. False. Perfect. So now let's change this to 10. True. Yes. Okay. Perfect. True. Now let's, I don't know, let's pick something else. Let's do 1, 2, 3, and let's do 1, 2, 3. True. Perfect. Okay. Works. Awesome. 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 Prefix matched. Okay. So we kind of left with 3 the most difficult methods. Which one are we going to solve first? Which one are we going to do first? Let's do, I think this one is easy, right? So add all digits in odd places from right to left in the card number. Okay. Sum of odd places. Odd place. Okay, so what does that mean? That means if we have a number like 1, 2, let's do the opposite, 5, 4, 3, 2, 1, then we need to sum up all the digits at the odd places, which means it's 1, 3, and 5. We need to sum them up, and we need to return the result, right? So 1 plus 3 plus 5 gives us 9. Okay, so we need to return 9. So if we have, for example, 6, does it change anything? No, because it's 1, 3, 5, right? So we start counting from 1, and we start counting from the right. So that's the first digit, third digit, fifth digit. Okay. So if we add 7 here, that means we need to add 1, 3, 5, and 7, right? So that's going to be 16. Okay, perfect. So the question is how to do that. How to do that. How to sum them up. So let's remember, how did we solve that problem where we needed to spell the same number backwards? Okay, so how did we do that? We chopped off the last number, the last digit, and printed it out. Then chopped off one more, printed it out. Chopped off one more, printed that out, right? And then by the end of doing this, by the end of the while loop, we had 1, 2, 3, 4, 5, 6, 7. Okay, so how did we do that? So imagine we're solving the same problem as we did last week, when we just need to print out this number backwards. So we did while, okay, while number is less than greater than 0, right? While number is greater than 0. Yeah, okay. So what did we do? We divided number. What did we do? I think we got a percent sign, right? And we printed that out. Printed that out. Okay. Yeah. And then we divided number by 10, right? So by the way, this is the shortcut for number is equal to number divided by 10. Okay. And that's it, right? Yeah, I think that's it. So let's try to, I'll return 0 just for the sake of it, to be able to run this method. Let's try to run it. Let's try to test this method. Let's say 1, 2, 3, 4, 5, 6. So it should print out the same number backwards. Yeah, so 6, 5, 4, 3, 2, 1, 1, 0. Y0. Ah, because I'm printing out 0 here, right? Oh, yeah. Yeah, because I'm printing out the result. Yeah. Okay, sorry. So we need to, let me do the same thing over here. Yeah, so 6, 5, 4, 3, 2, 1, 1. Okay, perfect. It works. Awesome. So that's what we did, right? So now, what if we do exactly the same thing, right? However, we will kind of skip. Well, first off, let's try to sum all of them up. Let's try to sum up all the digits. So let's do int sum is equal to 0, right? In this case, what do we need to do? Instead of printing that out, printing out the last digit, the digit which we chopped off, we just need to add that digit to sum. Sum is equal to sum plus this. Okay? And then we're going to return sum, and then we're going to print it out. Let's do this. Yeah, okay, perfect. So let's comment that back in. Let's say this. Okay. So in this case, what do we need to? What do we expect to see? We expect to see the sum of this all of the digits 112, which is 4. That's what it should be. But plus possible loss to conversion. Why? Ah, because it's ln. Ln to int. Okay, so we need to convert this into an integer. I would say even this. So we'll first need to chop off the last digit and then convert that into an integer. Okay, 4. Is it the sum of them? Yeah, so 1 plus 1 plus 2 is equal to 4. Perfect. Okay, let's increase this. Let's do, I don't know, 9. Okay, so 5 9s, so we should get 45. 45, perfect. Okay, it looks like it works. Awesome, cool. Where are we? Yeah, okay. So now we summed up all the digits, right? Not the digits which are located at odd places, but all of them. So now what do we need to do? We basically need to skip every other digit. Okay, so how can we do that? We can create a variable called, let's say, counter. Counter is equal to 0, right? And in each iteration, we can increment this counter. Counter plus plus, okay? And so while thinking about should we add the new digit to the sum or not, what should we do? We should check if the value of counter is even or not. So for example, check this out. At the very beginning, counter will be equal to 0, right? So when counter is equal to 0, should we add 1 odd places, right? We should, right? So that means we should add 1. And then in the next iteration, counter will be equal to 1. Counter will be equal to 1. Should we add the second digit number 2? No, we should not, right? So we should skip it. So when counter is equal to 1, when counter is equal to 0, we should add it. When counter is equal to 1, we should skip it. Then when counter is equal to 2, we should add it. When counter is equal to 3, we should skip it, and so on and so forth. That's why when do we need to perform this operation? We only need to do that when counter is what? Is even. Only that case. So when counter is even, when counter %2 is equal to 0, right? So when counter is even, we need to divide it by, sorry, we need to add the digit which we chopped off to the sum. Okay? So let's try to do that for this number. Okay, so let's do, I don't know, 4, 3, 2, 1. Okay, so in this case, the result should be 1 and the sum of 1 and 3, which is 4, right? Is it 4? 4, perfect. So let's add some. Let's add 5. Okay, so in this case, nothing should change because 1 and 3. No, hold on. No, yeah, it should change. 1 and 3 and 5 are located at odd places, so now it should change. So let's see if it changes to, what is it, 9? 9, perfect. If we add 6 here, in this case, nothing should change because we have 1 plus 3 plus 5. Okay, so nothing should change. Perfect, okay. And now if we add 7, we basically add in a digit which is located at the odd position. So now it should be increased by 7. So now it should be 16. Perfect. Okay, awesome. So looks like it works. Whoo, very, very close to finishing that, right? So we did what? We did this one, this one, this one, this one, this one, right? So now we need to get this one working. Sum of double even place. Sum of double even place. Sum of double even place. It's located over here. Okay, so what do we do here? Let's say we're given this number 5, 6, 4, 3, 2, 1. Okay. If we're given this number, we need to double up all the digits which are located at even positions. So which is 2, 4, and 6. Okay, so we need to double them up. So 2 times 2 equals 4, plus 4 times 2 is equal to 8, plus 6 times 2 is equal to 12, right? But we need to change this 12 to 3, so I'm gonna kind of say it's 3. Okay, and then we need to add 4 and 8 and 3, and to get 15, right? 4 plus 8 is 12, plus 3, 15. Okay, so that's the idea. Awesome. Okay, so how do we do that? As you can guess, it should be very, very similar to this, to sum of odd places, right? We just need to change from even to odd, because here we summed up all the even, and here we need to odd, and here we need to sum up all the even places. Okay, so let's copy the code, and let's think how to change that. In sum is equal to 0, count is equal to 0, blah, blah, blah. Okay, so how can we change, how can we swap odd and even? How can we skip now all the odd places and sum up all the even places? Okay, so the easiest way to do that is to still have the counter, right? But to sum up the numbers not when it's even, but when it's odd. Okay, when it's like this. So if the counter is odd, again, at the very beginning, what is it? Counter will be equal to 0, right? So counter is odd. In this case, sorry, counter will be equal to 0, which is even, right? In this case, we should skip this line, right? We should not add 1. Then in the next iteration, the counter will be equal to 1, which is odd. And in this case, it's going to add the 2. And then in the next iteration, the counter will be equal to 2, which is even. It's going to skip this line, and it's going to skip 3. Then the next iteration counter will be, what is it? 0, 1, 2, 3, and it's going to 3, right, which is odd, so it's going to execute this line, which means it's going to add 4, and so on and so forth. Okay, so again, I would highly recommend, if it doesn't make sense, and I know it may be difficult to understand, draw these lines and kind of imagine how kind of unwrap this loop. Imagine how it works on a piece of paper. Once you do that, you will be like a lot easier to understand. You'll be writing them, a lot of those loops. Okay, yeah. So we need to do that, but also on top of that, we need to double them, right? So we need to double them. So we need to say 2 times the digit, and also if they're bigger than 9. Right? So for example, 12, right? We need to sum up all the digits, for which we have this method, right? Perfect. Yeah, so we're going to say get digit, and inside of that, we're going to do this. If that kind of writing is too complicated, what you can do, you can break it down in a couple of lines. For example, int, I don't know, a is equal to 2 times this, right? And in this case, here you can just say a. Okay, so in order not to kind of make it longer, it's completely up to you. Of course, it's much more understandable if you just break it down into a lot of variables and making like meaningful names for them. Okay, so for example, I can do, I don't know, what if I want to break this down as well? So what if I say int b is equal to 2, let's say this, okay, 2 times b. Okay, and this should be easy to understand. Okay, awesome. So int b, a 2 times b, and then get digits a. Yeah, that's what it should be. That's what it should be. Looks good to me. Let's see if it compiles, just to make sure that there are no syntax errors. Does it compile? Yes, it does compile. Now let's test it. Let's test it. Let's test it. And now we need to be very careful. So let's test this number. As I said, the result should be 15. 15, 15. 15, perfect. Okay, now let's add maybe one more. In this case, nothing should change, right? Because we add in the digit which is located at the odd position. Okay, so nothing should change. It should be, it's still 15. Perfect, okay. And now let's add one more, let's say 1, right? So in this case, it should be 15 plus 1 times 2, right? So it should be 17. Awesome, cool. Cool, 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 it works. Perfect. So we basically conquered all the methods, apart from the main one is valid, right? So what do we need to do here? We need to make sure that two conditions are true. First off, one of them is a prefix, and secondly, if I just do all of that, that's going to be divisible by 10. Okay, no problem. So two conditions, right? So let's conquer the second one first. Boolean is divisible by 10. Okay, so is divisible by 10. So let's see how can we make sure it's divisible by 10. First off, we need to do this, right? So what is that? That's sum of double even places. So int, oh yeah, let's do that, is equal to this number. Okay, so what did I do here? I created a variable with the same name as the method, okay, which is totally fine, by the way, in Java. In C, in C, no, hold on, in C. Yeah, I think in C you cannot do that. In Python you cannot do that, but in Java it's fine. Okay, so Java will be able to understand that if you're talking about this as an integer, that means this. If you're talking about this as a method, that means this. That means this. Okay, so that's what I need to do first. Then, okay, so I do that first. I sum them up as 37, right? Then I need to do the same thing with odd places. So int odd, 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 number. Okay, some word places number. Okay, then what do? I need to sum those two up, 37, 38. Okay, so I need to sum them up. Let's say int sum is equal to these two. Okay, then what do I need to do? I need to make sure it's divisible by 10. Okay, so if sum %10 is equal to 0, right? In this case, it means it's divisible by 10. And then I'm going to, let's say, return true, else return false. Okay. Okay. Yeah. So let's try that. Let's try that. So that's only one condition, right? Again, so we need to have two conditions. Okay, so that's one condition, and that's those 6 steps is the other one. So let's try the second condition only first. So how can we do that? Let's try this number, which is invalid, right? So it should return us false. Okay, so let's do 4388, 4388, 5760. 4388, 5760, 1840, 2626. Okay, so that should return us false. No, too large. Okay, so we need to convert that into one. It's automatically understanding that as an integer, so I have to kind of create a variable input. Okay, so let's do this. No. Too large. Integer number. Why does it say integer number? Long input. Expected. Huh, I thought it's going to be warning. So most likely, like maybe in your Eclipse, it's going to be warning. Yeah, so I was thinking that's an integer, although it's a long. Yeah, okay, so it's an error with parsing. Okay, so blah blah blah. Create long in Java. L, okay, L at the end. Yep, yeah, that should help. Okay. False, perfect. Okay, so that gives us false. Now let's try the same thing in order to return true. True. So what is that? It's 40. Well, first off, let's copy that. We'll probably need that in the future. Okay. Invalid. Okay. So now let's copy this. 4388. 5760. 4388, 5760, 1841, 0707. Okay. So let's try that, and I hope it's going to be true. True. Perfect. Okay, looks like it works. Awesome. Okay, so that kind of proves, of course, we only had 2 test cases. It kind of proves that we satisfied the first condition. So then this is true. This is false. Okay, cool. So after doing that, we have the first condition, it's either true or false. We satisfying that. And then first condition, right? So we need to make sure that either 4 or 5 or 37 or 6 is a prefix, right? Okay, so let's create another Boolean variable called the right prefix, okay? And we're going to assign that to true only if one of those will be a prefix of a number. So how would I do that? We need to say if, then right prefix is equal to true, else right prefix is equal to false. Okay, so what do we need to put here? That's going to be true if prefix matched, right? If prefix matched of our input, no, not the input number, our number and 4, right? So if this returns true, then we assign the right prefix to true, right? But that's not the only condition. So if this returns true, or and remember how we do the or, right? If this returns true, or 5, same thing with 5 returns true, or same thing with 37 returns true, or same thing with 6 returns true. Okay, so if one of them are true, if this is true, or this is true, or this is true, or this is true, obviously they cannot be true like all at the same time. And then we say that the right prefix is true. Yeah, or we return false, or it's false. Okay. Let's say return. Let's test the second condition only. This condition, right? Okay. So now, what do we know? This one starts with 4. Okay, so that should return us. That should return us true. I think. true. Okay, so now let's change this such that it's gonna start with 5, for example. True. 5. Okay, yeah, so that's true. Let's do, let's say 1. False. Okay. Let's do just 33, right? So it's not 37. Let's test this condition. So it's not 37, it's just 33, right? So that should return as false. False. Okay. But now if I change this to 37, that's true. Okay, awesome. Cool. Cool, cool, cool. So what was the right number? 43. Okay. Yeah, so that's it. That's it. So now we basically have kind of this condition and this condition. If both of them are true, in this case, we return true. Okay. And that's the end of the program. So if this is true and this is true, then we will return true. Okay, else we return false. Yeah, that's it. Okay, so this guy should be valid. This one should be invalid. So let's see. True. Okay, so now if we change this to this, it should return as false. False. Okay, perfect. Awesome. Yes, of course, only 2 test cases is not enough to prove or disprove that this works correctly. Technically, like once you write this code, you need to give it to a tester, quality assurance person, quality assurance specialist, and he will be able to test it for all possible combinations of numbers. Or like if a programmer is the same person as the tester, which actually happened to me, then in this case you would write test cases yourself, and you want to make sure that for all possible inputs, it always spits out the right decision, true or false, the right verdict. Okay. Okay. What else do we need? We need to have an input, right? So let's say import java.util.scanner. Okay, and then we're gonna say scanner input is equal to new scanner system.in. Okay, and in this case, let's say in, right? And here we're gonna say in dot next lawn, right? Next lawn scanner. Java.util doesn't exist. It's lowercase j. Okay, awesome. So yeah, so it waits for me. I'm going to type the invalid number first. Okay, without L. Boom, false. Awesome. And I'm gonna do the same thing for valid number. True. Okay, perfect. Yeah, so looks like it works. So after that, normally what you would do, you would polish the code, you would make sure that it's readable, you would change the variables, names of the variables, right, in order to make sure that someone else who is going to read this code, or you, maybe 6 months later, who'll be reading this code, will be able to understand everything what was going on. You would add comments, you would delete all of these useless comments, you would add the header comments, header comment. That's what you need to do, okay? But other than that, I think I have successfully accomplished the mission. I solved this problem. Hope you, by the way, you, just to make sure you understand. So I was Googling some of the functions, some of the methods, right? So if the method belongs to Java library, right, in this case, that's not considered to be cheating. For example, if I Googled prefix, not prefix, but substring, right? So, or like parse lawn, that is all part of the Java library. That's not considered to be cheating, right? Because I'm using the standard methods of Java, of libraries, right, of Eclipse. But if you are Googling something like how to find prefix in Java, Okay, so if you go, let's start with, yeah, so if you find something like this, no, that's an example. Okay, longest common prefix. So for example, if you go over here, find Java code, Java, and if you do this, and you just copy that over here, so this is cheating. No matter, even if you're going to change the names, the substrings, the variables, that will be considered to be cheating, and that's plagiarism. Okay, so please, please, please do not do that. Only use the stuff which is written in the slides, in the textbook, and if you find something online, just make sure it's a part of a Java library. Do not copy like the whole thing. Okay, hope you guys enjoy that. I'll see you on Thursday. Keep in mind that we're going to have a quiz. Quiz will be okay. So first off, this is of course an overkill. I'm not going to be asking you anything related to that on the final exam or in the quiz. Okay, so that's just an example. I hope that inspires you in some way. But on Thursday we're going to have a quiz only on what we covered on Thursday, like last week. Okay, I'll see you guys later. Bye bye. Have fun.